Hello guys, welcome back to my channel again. Today I decided to talk about the state of nothing, or just nothing. So what is nothing? Now let's forget about the language. Let's take a point of reference. When you're talking of nothing, that's a very general word and there's a lot of meaning to it. Like nothing in reference to what? Suppose I tell you, go and pick an orange from a basket. You want to eat an orange? There are oranges in that basket. Go and pick an orange. So when you go there, you find there's no orange. Then you tell me there's no oranges. Or I ask you what? No, there's no orange in the basket. You mean there's nothing? No, there's nothing there. You see, it's a point of reference as to how are you using this word. For example, if I give you a cup like this, I tell you there's tea in this cup, and then when you try to look inside, you don't see tea. You tell me there's no tea, there is nothing. But this is not what I'm talking about. I guess you guess where I'm going. Yeah, we're going to something we call empty space. What's an empty space? And before we go there, let's start from the earth here, or right from the beginning. From where did everything come from? In the very, very beginning, before this thing they call Big Bang. Big Bang is a theory. It's not proven. I mean, how do you prove whether there was anything like Big Bang at all? But it is held to have taken place 13 billion years ago. According to what scale, which scale is that? Astronomical scales? Due to which calendar we're using? Anyway, let's forget about all that. So, it's said that before the Big Bang took place, it was extremely cold. Where did the cold come from? It was so cold. And then there was this dense hot thing which exploded. And then the Big Bang was born. Yeah, but if you go back even before that, cold also is something. So what was actually there? Yeah. There was a space, or what was there? Even space is something. Before space, before everything, what was there in the very, very, very beginning? Is there anything like beginning, or is just a figment of our own imagination? I mean, we as human, because if you tell a dog the Big Bang, or a cow or anything, they don't know what's Big Bang. But you, as a human being, you have the intuition, you have the intelligence, the thinking, the brain. So you think, and you have this word in you called nothing. What is nothing? Nothing something. So it seems that things might have come from nothing, according to our point of understanding. Maybe there's nothing like nothing. It's just our thinking. So, okay, the Big Bang was born according to what the theories say, and then it expanded so fast and then cooled down, and then has been expanding ever very fast, even at the speed of light, and forming all these things, galaxies and everything. Yeah, who knows? Really, did this thing happen? So the state of nothing, what's the energy of nothingness? Let's go there. Now, each cubic centimeter of empty space contains about 10 raised to the power minus 25 grams of invisible matter, or its equivalent of vacuum energy. So here we have coined the word vacuum. What's really a vacuum? Vacuum means there is nothing there, from my general understanding. Now, this is 29 order of magnitude smaller than the mass of matter, okay, in a cubic centimeter of water, or 5 order of magnitude smaller than the proton mass. So empty space is not really empty. Even before even we go there, what is space? Space and gravity. Space. What is space? Space is something. What's the concept of nothing? The concept of nothing is that it's a concept, it means a complete absence of something. The opposite of being is not being, right? It's quite opposite. So it's a void, it's emptiness, sorry, right? So what is nothingness made of? With no particles, no radiations, no electromagnetism, nothing is there, you know. Radiation, identify quantas and so on. So it's nothing. That's the definition of nothing. But really, in the real sense, there's nothing like nothing, because if you take this cup, sorry, I'm gonna pour water inside. This is a cup. So let me pour water. I think it's, you see, I'm putting liquid into this water. So now, what is inside this cup is liquid. Now matter exists in three states: the solid, liquid, and gas. So in the absence of water here, there's still molecules there, air molecules, you know. We have all sorts of radiations and waves, like the infrareds and microwaves and sorry, air molecules which will be inside this cup even without this cup. And these things are forming a blur, you know, of interaction. If you talk about quantum field theory, then we have quantum mechanics, we have classical field theory, and you have special relativity. You can see that there is no time, according to uncertainty principle, when there will be nothing here, because you cannot, according to Heisenberg, you cannot fix a position of something at the same time its momentum. There's no one point where you can have seamlessly the two at the same point, fix them, and then you have a zero state. So there's no point time when we really get absolute zero. And if the absolute zero does not exist, so when was there nothing, right? Sorry, I have to take some water. You know, sorry, we humans, we have to take water. Everything takes water. Water is life. 80% of our bodies are made of water. So we're also made of these things. We are part of it. So I'm talking about the emptiness. There's no nothing like empty. Now let's come close to Earth. Yeah, let's come close to Earth and try to analyze what is here with us. Sorry, I'll just put some points down somewhere, which I'm going to show you. So here in the planet, atmosphere is composed of about 78% of nitrogen, 21% of oxygen, we have 0.9 argon, and the rare gases like methane, water vapor, neon, and some of the other gases that make up the remaining 0.1%. This, as far as this planet is concerned, we call Earth home, our home. If you go out, now before that, there's about 5.5 quadrillion tons of matter in the Earth's atmosphere. So there's plenty of matter out there in this planet. So what if you moved out of the planet and go up to interplanetary? So the higher you go, the less molecules will be there, the less matter will be there, the less pressure will be there. You go to the interplanetary, you go to interstellar, then you go to intergalactics. So different matter states are there. Like if you go to interstellar, for example, you find there the molecules are there, the radiations there, the dust there, the gases there, like 90-something% gas, yeah, and liquid. So if you go higher than that, maybe you find only hydrogen, plasmas, and by cubic centimeter, maybe, for example, you might find something like 10 billion to raised to power 10 billion. And if here on Earth, for example, we have 10 raised to power 25 septillions, yeah, quantity of matter. And the way you go up, the matter reduces. Now we have something called deep space, empty space, dark space. You don't see anything there. Even sound does not travel there. There's less matter there by cubic centimeter of empty space. There's nothing like empty space because it's a vacuum. Now, suppose we had to take this cup. I'm still using this cup. This is also something, and suck all the air, suck everything from here, and cover it and freeze it up. So, trying to get an empty state, emptiness here. So, let's reference this to empty space somewhere in the. There's somewhere in the universe where there is nothing. That's hypothetically, let's say there is nothing. So still, we'll have something called visual particles. If you had to take everything, suck all the air, suck everything, dish everything out of it, you still have visual particles. Because we have the nucleus, the nucleus, the quarks and the quarks, the gluons, which have mass and all that stuff. So if suppose you took everything, still you'll have dynamic vacuum, because it's not clear whether they are really visual particles or it's the vacuum itself, because there are these things which come out of existence in a split time. Actually, they vanish quickly than you can measure them, and they are thought to be particle antiparticles, which annihilate each other. They annihilate each other and quickly disappear. They come from nowhere, actually, born out of nothing. And this is a mystery of everything. Nothing seems to be something, really. And in the very, very beginning, there was nothing, but there was something, because everything seemed to come from nothing. Nothing is sizzling with, or sitting with, or bristling with visual particles. And the word visual, what does visual mean? When I tell you visual, it means something that's not really there, but it can be there. Whether from an abstract sense, I don't know. So the state of nothing is nothing, but this word is just like it's a figment of our imagination, and there was no time when there was nothing, and probably even before the Big Bang theory. Now take it this way. The Big Bang was born. Was it the only thing at the time that came to be, or it was just a blur of other things which formed along with the Big Bang, which you don't know of? Maybe the universe formed the way it formed, and other things formed, because there's this theory of multiverse universes or other things that might have formed along with this one. And now we have such a large thing called space, invisible, the universe, observable and unobservable. If you were to go to the end of the universe, if by any magic somebody was to drop you, or something was to drop you at the end, at the edge, if there is any edge at all, what is beyond the edge? Maybe another universe, or how do you perceive or conceive emptiness or nothing? Because nothing is something. Can you imagine a world without a beginning, infinity? How is that possible? So there was no point in time when things started. Maybe things have always been there. And we have this exotic matter. We have minus matter, minus energy. And if you supercool something to maybe 273 kelvins, matter, if it's water, it starts to behave differently. For example, water will climb the wall. This is strange properties comes up in different states. That's why this I agree with this Roger Penrose, I think it's Penrose, who says that these things, maybe, I don't know whether that's what he says, it's a cycle. At some point something will mutate, like just the water, when you boil when it's a solid, can turn to a liquid, then turn to a gas under different conditions. Maybe these things go around in a cycle like this, right? In different states, they go, and you can draw this thing. Sorry, I'm just not looking at it. You can draw something like this, and say this 90 degrees, and it's rotating 360 from here. Let's say this is where here we have 90, and then this totally 180, 360 or something degrees in a complete circle is 360. These things seem to be going round in a cycle, right? So in different state, this thing will be different. So there is no point when there can be nothing. So we have something like infinity. This sign is called infinity. In maths, we have something called, sorry, today is a talking video. We are trying to analyze the state of nothing. In maths, there's something called complex number, imaginary number, because let's try to derive mathematically the state of nothing and say nothing, we give it the value I. Okay? Now, if you square this value, it's going to give you -1. Okay? And if you try to find the square root of this, you try to find the square root of -1, it's going to give you I. Okay? And if you square, if I is equal to -1, if you square I, now we are trying to derive the state of nothing mathematically. Maybe it will help us to reason out. We'll get -1. Now if you multiply -1 times -1, it's going to give you +1 mathematically. So we have come from thinking, which is a figment of our imagination, to 1, instead of 1. And we call this here, this thing, we call it negative energy. Negative energy. By the way, what is energy? Energy, there's an equation which says that E, which is energy, is equal to matter and c squared. I guess I'm right. Energy is matter, and this stands for light, speed. Square this, and this will give you energy. In other words, energy is matter, and matter is energy. So if energy is something, in my own opinion, is indestructible, there must have been energy. Even from the very beginning, the state of nothing was energy equal to energy. So if it is equal to energy, and energy is indestructible, it means that energy was changing from one state to another at some point in time. And now we have the universe. After some time, maybe the universe will decay and form something, and the cycle will begin again. But I'm being hypothetical here. So I was talking about having many states of things, and let's think of anything mixed together. These are states of energy, different things. Yeah, if this thing comes to 0 point, then these are there. If this thing comes to 0 point, then these are there. These are an uncertainty principle. Heisenberg uncertainty principle. So I've just done some work on it somewhere, and I think I'm going to read it to you so that we are in the same page. He says that in quantum theory, in quantum theory, the uncertainty principle allows the vacuum of space to be filled with virtual particles. It allows, I don't know how, whether that is real. You know, sometimes when we just think of something and make it like a gospel truth, we say it allows. Is it real that this thing is there? Okay, let's go by what it says. It allows the vacuum of space to be filled with the particles and antiparticle pairs, which appear spontaneously and exist for only a short time before they typically annihilate themselves again. So some of these virtual particles can have negative energy, right? This is what I'm talking about. Things coming from nothing. So in other words, there's nothing like nothing. So even if you want to go beyond everything, from the interstellar to intergalactic, and even beyond, I don't know what lies beyond the intergalactics, we'll still have something. Yeah, there's laws of nature, laws of physics, and maybe you reach a point where it will come back to where you started. So it's difficult to imagine the state of nothing. I think the reference that we use it with, in reference to what? The Big Bang theory is just a theory, It's not something that we can say, okay, this is a gospel truth, this is what really happened. Nobody knows what really happened, or whether there was a Big Bang at all. We're just guessing. But I'm not out to discredit the scientific world. He says there's a Big Bang. I'm just thinking. It's my own thinking. You can choose to ignore, to say no to what I'm thinking, but these are my thoughts. So what does the theory of inflation tell us? That the period of time before the Big Bang was extremely cold, almost of absolute zero, and it was empty of everything, but empty space. So does it really make sense? Let's see. Let's reason here. This is a theory of inflation which tells us that the period of time before the Big Bang, not Big Bang, the Big Bang took place, was extremely cold. So where did the cold come from? Okay, let's say there was no sun, there are no stars. So it's only it's understanding that if there's no heat, then cold will be there. Okay, and if there's no cold, then what will be there? It's difficult to say. So extremely cold, almost absolute zero. Almost, not really absolute zero, almost. Because here we go against Heisenberg uncertainty principle, which says there's no way you can have absolute zero, because you cannot fix the position of an electron, for example. When you try to do that, the momentum will go. If the motion, you can fix the motion, then you can't fix the momentum. There's no point where you'll have the two of them fixed together. Okay. So, and it was empty of everything but empty space. It was empty of everything but empty space. So space is something. What's really space? Yeah. And that empty space carried energy that stretched the universe out to this enormous size. And the initial state before the Big Bang. So there was empty space before the Big Bang took place. And we know the space as we know it, it can be curved by, according to general relativity, the laws of Einstein. We don't know what Einstein is also, right? Einstein is also somebody like you who imagine these things out. He says, according to general relativity, gravity has the ability. Actually, what is matter? Let's go to matter, for example. Matter in nature attracts, and in matter that I am made of, you are made of, everything's made of matter, radiates something called gravitons. So these gravitons, which travel the speed of light even faster, can form gravitational field. Now, gravitational field is what attracts. Yeah, so matter attracts. So we have space. As I've told you before, every cubic centimeter of space has 10 raised to the power minus 25 septillion, that is, grams of invisible matter, or its equivalent of vacuum energy. So energy is matter, so it means there's some small matter in it. So I'm lost in thought anyway. I was talking about the state of nothing. You see, it's even confusing me. I really don't understand how things could have come from nothing. At some point in time, something must have come out of nothing, absolute nothing, and nothing as by our figment of imagination. Something must have come from nothing. That's if we deny the religious. We are not going to philosophy and religion. Because if I go to religion, then I'll say God created. Yeah, I don't want to go there, And if we go to philosophy, the Greeks argued that it's impossible to have the state of nothing. They had their own reason for that. But even for you who's watching this video, what do you think about nothing? What is nothing? Right? What is this thing? How did these things come about? Now I have a point about the interstellar space, what it contains: vast quantities of neutrons, charged particles, atoms, molecules, dark matter. What's dark matter? We don't know. Nobody knows what's dark matter. Okay. And photons. Okay. Ranging from high energy radiation to the sluggish light of the microwave backgrounds, albeit rather sparsely spread out. And that's why even sound does not travel up there, because there's no medium. The molecules are widely scattered, there's less pressure. Only light master is a lion in everywhere. They can travel there. Light, the photons, they travel there, but not sound or another thing. So these regions have very low densities. I've listed the points, so I'm trying to read them to you, and consists mainly of gas. That's 99%, and dust. In total, approximately 15% of visible matter in the Milky Way is composed of interstellar gas and dust. So this is a region up there. I'm not talking of the Earth or the solar system, even the Milky Way. This is a galaxy. You know, we have intergalactic. We're talking of interstellar. So intergalactic as its own. I've already told you what's available here on Earth. We're now using Earth as a reference point. We're not in Jupiter or Mars or Venus or Mercury or Pluto or whatever. We are here on Earth. So we are using Earth as a reference, you know, because here is where, actually there's a theory or thinking that we are living in a black hole. The gravity is attracting us here. So all these things inside a black hole. So the material is called the intergalactic medium. The density of the intergalactic medium, so that's IgM, is 5 to 200 times the average density of the universe. It consists mostly of ionized hydrogen, I plasma, consisting of equal numbers of electrons and protons. So it's quite difficult to tell what is nothing really in reference to what we are using, but here we are concerned with the Big Bang. Yeah. It's difficult to say we have nothing, because even if you took an empty cup, it's not really empty, because gas is, and there is according to ascertain, they say even if you sit like this, there's a small amount of heat that is coming out of this thing, just as cold as it looks. If you follow these laws, there's no point where there's nothing there. We have the exotic matter, and we have the electromagnetisms and all stuff, microwaves. These are things you can't see, but they are there, because you know your eyes can only see light. For instance, you cannot see infrared. Let's assume we were able to see these things. We'll be seeing a lot of stuff, you know, some that you don't even, they can even boggle your mind. So it's even good that your body can withstand all these things, right? So the question of nothing shouldn't trouble your mind, because really what is nothing? Nothing is something, and something is nothing. At some point of time, maybe there was never a beginning. This is a world without a beginning or an end. Because if everything came out of energy, and energy is matter, and energy cannot be destroyed, it means that energy was changing from one state to another. So even in this present state where it is in a solid state, at some point in time it may decay. And actually the predictions that I'm not really a prophet of doom. I don't even say this is what will happen. But there is something in the physics circles which says that this universe will end 4 billion years from now. Am I right? Yeah, 4 billion years from now. Is it 4 billion or 400 billion? I'm not sure about it. Oh yeah, there is something about the Andromeda going to collide with Milky Way, and that will be around 4 billion years. And you can imagine what will happen. It's like when you're saying, okay, maybe everything's going to be a big, huge, gigantic black hole. You know what's a black hole? We have done that before. Then we'll have a singularity, because in some cycles they say that everything started from a singularity, and we know what's a singularity. That's where matter is highly concentrated, and the laws of physics don't apply. Space and time is not there. Actually, time time was created and space during the Big Bang. So before the Big Bang, there was no time. What is time really? They say it's a fourth dimension. You have 3 dimensions, X, Z, Y. 3 dimension, and then time. What is time and what is space? Some of the things we imagine. So when we talk of time, we talk time in reference to something, like when the sun rises from there, and we have made clocks, modulars, watches, which shows you at this point the sun is here, the sun is here, the sun is here. We call that time. But what's really time? Is it something physically? Is it really? What is time? Time is a reference to something. So when you said that time was born when the Big Bang took place, you have to explain really what you mean by that, because space, you can understand, okay, space is what you see, you can call space. Empty space, or space filled with matter, space is space. Is space, what is really space? What is nothing? And what is space? Do you even imagine that how the temporary nature of things, even we humans, everything, stars, they exist for a certain period of time, and the physicality of them, there's something called entropy, takes rid of them and renews them, in a cycle. So similarly, even the universe, if at all is what we think, it's gonna disappear at some point in time. Sorry. So I leave you at this for you to reason out and tell me what is nothing. So we have started from the Earth, we went to the planetaries, to interstellars, to intergalactics, and beyond, even beyond the universe. What is really there? What is nothing? Is there a state of nothing? Does nothing exist? Or is it just a figment of our imagination? I repeat that word. Maybe it's us, our nature, that we conceive and think this way, and our friends, our companions, whom we dwell with together here on earth, have no issue with that. They don't know what's the time or what's nothing. You ask a dog or a cat, they don't know what's nothing or that. They just live, and that's it. But we have this brain that we are given, and we think, what's nothing? Is there something like nothing? Yeah. It's difficult to tell what was there, whether this Big Bang thing is anything to go by. Sorry guys, maybe I've gotten out of myself. This is a question I've been very much obsessed with right from the beginning, when I usually thought, what is nothing? What is the state of nothing? I mean, what was there before the Big Bang? Even